Hello, today we're going to be looking at a special right triangle that actually comes up a lot in higher mathematics. Those of you moving on to pre-calculus and calculus, you should be familiar with this 30, 60, 90 degree triangle. Now we're going to go through an investigation that typically we do together in class, but I'm going to walk you through it. So if you do have this printed out, it's nice to follow along with me. Okay, so we've got this triangle DEF to the right. It's equilateral, which again means, all three sides are congruent, so 2, 2, 2. Also, we know that 60, 60, 60, all of the angles are congruent. So draw an altitude from point E to DF. Mark a right angle. Okay, so that was step one. Label the point where the altitude meets DF as point C. Determine the measure of CEF. So if we draw this altitude down, CEF, because of symmetry, is going to bisect the 60 degree angle. So this will be a 30 degree angle. Okay. So when we determine the length of CF from the middle to here, notice this was equilateral, this was length 2. Well, it's going to cut this in half. This will be 1. Okay. Now it says to use the Pythagorean theorem to find the length of CF. So we're looking at this right triangle, and we can label this length x and use the Pythagorean theorem. X squared plus 1 squared equals 2 squared, and solve for the missing length, which, if we work out, x squared will be equal to 3, so x is equal to root 3. So this height we just determined was root 3. So what we're supposed to see here is this 30, 60, 90 degree triangle has length 2 for the hypotenuse, this side is 1, and this one is root 3, the height. Now, we're going to see a shortcut in a second. So usually we do this in groups, but again, like I said, I'm going to walk you guys through this. Consider the triangles shown below. What is the same about these triangles and triangle CEF? Well, CEF, the one in pink, and all three of these triangles, you should see that they're all 30, 60, 90 degree triangles. And can we prove that these triangles are all similar? Yes. Hopefully remember by angle similarity. If they have two angles in common, the third one has to be in common, and therefore we have similar triangles. Okay, so in groups we typically do the Pythagorean theorem 3 times to solve for this missing height. So we would do x squared plus 2 squared equals 4 squared. And on the second triangle, x squared plus 3 squared equals 6 squared. And x squared plus 5 squared equals 10 squared. If you want to try to work these out all on your own, you could pause the video, but I'll work it out for you if you want. It's x squared plus 4 equals 16, so x squared equals 12, which means x is the square root of 12. And remember, we always want to simplify our radicals. So this height on the first triangle will be 2 square root 3. Okay. And when we do the second one, what is that? So x equals the square root of 27, which simplified gives us 3 root 3. Similarly over here, when we work this out, we'll get x squared equals 75. So x is the square root of 75, which simplifies to 5 square root 3. So hopefully, I know I went through this rather quickly. You can always rewind it if I went a little too fast. But maybe there should be an aha moment. We're seeing something kind of cool in this pattern. Yes, there is a pattern. This will always be the pattern, and because these triangles are similar, their corresponding parts should be proportional. So you can see that the side opposite the 30 is always going to be half of the hypotenuse. We're going to formalize this on the next page. And whatever length this is, you just multiply by root 3 to get the side opposite 60. Okay, So notice, if you look at this short leg, we call this the short leg because it's opposite 30. I can multiply by 2 to get 6, or multiply by root 3 to get this length. 5, we multiply by 2 to get 10, multiply by root 3 to get that side length. That's the pattern. So what's kind of cool is you don't have to do any of this work anymore. Mathematicians are lazy and we love shortcuts. And if there's a pattern, we will use it. Okay? So on number 9, what patterns do you observe with the side of the hypotenuse lengths? Does this seem to be a repeating relationship between the lengths of the legs of the hypotenuse? Yes, we just discussed that, but 5 times 2 equals 10, right? We're just doubling to get the hypotenuse. Or 5 times root 3, we're getting 5 root 3. And again, yes, this will always be true because they are similar. Any 30, 60, 90 degree triangle, they're similar, so the corresponding sides will always be proportional. Okay, so we may need to split this up into 2 videos. Going through the examples tends to be a little more difficult, but once we kind of formalize this, you'll see how to kind of do some problems. So a 30, 60, 90 degree right triangle, okay, has 2 legs and a hypotenuse. Okay. And the side opposite the 90 we know is called the hypotenuse. So this one's going to be the hypotenuse. Then we have 2 legs. Now notice, we talked about this in class. If you have a smaller angle, we're comparing this side and this side. You can obviously see, if it's drawn to scale, that this side is shorter. But it's because it's opposite the 30. We call this the short leg. Okay. And the one opposite the 60 is going to be called the long leg. And that's what this is formalizing up here. The leg opposite the 30 degree angle will be called the short leg, and the leg opposite the 60 degree angle will be called the long leg. Okay. Now the relationship between the hypotenuse and the legs is what? So meaning, on the other examples on the other side, if I had a short leg, which was 2, we multiplied by root 3 to get the long leg, and we multiply by 2 to get the hypotenuse. So if you have the short leg, you just multiply by root 3 or multiply by 2. Okay. Another example, if I have 5, then the long leg will be 5 root 3, and the hypotenuse will just be double. Okay, sometimes we have to go backwards, but if you have the short leg, it's as easy as that. Now, what I tell my students to kind of memorize and to put in this picture is whatever length the short leg is, let's call this x. Okay, the hypotenuse will be twice that, so 2x, and the long leg will be x times root 3. Okay. So if you have this relationship memorized, it should help you. Now, some people don't like it in a picture. Some people like it written out. So there's one way you can say that the short leg times 2 equals the hypotenuse, and the short times root 3 equals the long. If this makes more sense to you, it's just something you essentially need to memorize. One of those things in math. Okay, and we already discussed this, but we'll put it down again. We know the hypotenuse is always opposite the 90. What angle is the short leg always opposite? Opposite the 30 degrees because it's smaller, and the long leg is always opposite the 60. Okay. So this kind of describes what the pattern is. In the next video, I'm going to be going over all of these examples and how to apply it.